Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. Today we're going to start entertaining the idea of decoupled recommender systems. Well, what do I mean by that? Today, pretty much any recommender system you're going to encounter is an in-house thing. If you go to Netflix, the recommendations you get there are from the algorithm produced by people who work at Netflix. But what if there could be a marketplace there, the way your phone has an app store? There could be an algorithm store. Of course, that would require these platforms to open up, but perhaps there's a very good reason they should do so. Towards that end, today we're going to discuss the Simulator for Modular Recommendation Ecosystem, or SMORES framework. We get deeper into these decoupling ideas and explore how SMORES can be an empirical tool for studying how ideas might play out in that space.
My name is Buhayh. I am a student at the University of Colorado Boulder, supervised by Dr. Robin Burke. I'm at the Information Science Department at that Recommender Systems Lab, and most of our work in this lab focuses around multi-stakeholder fairness in recommender systems. Yeah, and basically the work I do is mainly around evaluating alternative recommender systems.
You use the term multi-stakeholder. Could we talk about who those stakeholders are?
Yeah, so usually whenever we think about a multi-stakeholder recommender system, we think about recommender systems that work as matchmakers. So think about having someone who's providing a service. So for instance, if we're talking about Spotify, that can be the artist, or you think about a YouTube, that can be like a content creator, DoorDash, the restaurant, or the driver, someone who's receiving the service. So the one who's providing the service, we call them providers, and the person who's receiving the service, we call them consumers. And that's the user that we usually call that just the user on an everyday basis. And that's the person who's like listening to the music, making the order on DoorDash. We have the platform, which is something that we cannot ignore because there's a lot of conversation like, oh, we need to do the matchmaking, but we forget that the platform also need to, make money to keep running. These are the three stakeholders we talk about. And most of the time, when you see in the literature, whenever we hear user, we don't think of providers as users for some reason, but they are as valuable users in this whole ecosystem.
So when you consider fairness, is it for the provider, the consumer, or the platform? Or maybe all of the above?
All of the above, yeah. You need to think about everyone on the platform because recommendation as an ecosystem needs everybody to be happy to some extent to stay on the platform. So let's say if I join the platform as a provider, let's say a content creator, and my content is not reaching anybody, then I'm going to leave that platform. And then you would have like a platform with only like 3 or 4 content creators, which is like make the content. So like, how do you balance between all of these multi-objectives on the platform?
What would it mean for a recommender system to be unfair?
So the fairness issues in recommender systems are similar to like machine learning as a whole. So you have 2 fairness issues that you would usually find in the literature, which are representative fairness and allocative fairness. So let's start with the first one. Let's say representative fairness and talk about it in the idea of like recommender system. So let's say you have a job recommendations and we're recommending to females like a less paying jobs or like a specific stereotype of jobs, and you're presenting to males a different kind of job. So that's as a receiving end. Also, another way, it could be like I would jump on a search image and I look up, I don't know, an Arab man, or say like an Arab man. So like what kind of photo would you see whenever you look up that? Because that is in itself as a retrieval, so it's a recommendation. So that's the representative part. The other part is the allocative fairness, which is, let's say we were talking about like content creators, for instance. So the idea here, me as a new content creator joining the platform, will I get any chance to be recommended, or only like the very famous people on that platform will be presented to the consumers? So these are kind of like the 2 main things we talk about whenever we talk about fairness in machine learning.
Well, I know you probably can't have surveyed all of industry and all of implementations. There's a lot of recommender systems out there, but I assume most of these are written in-house. Is that true?
As like the recommender systems?
Yeah, so like at Spotify or YouTube, whatever they're doing, it's probably a trade secret by employees inside the company.
Yeah, exactly. I mean, the thing about recommender systems as a whole, they are multi-stage. So there are like two narratives. The first narrative, people think about recommender system as just like one algorithm. You just like put that algorithm and then you get a specific output. But in reality, that it's multi-stages. So for instance, we're talking about an enormous platform like YouTube. You cannot put every item, like those millions of videos, or maybe I don't know, billions at this point, you would put them in the algorithm, and they would spit out recommendations for a specific user because that's so many. So you have different stages. So you have the retrieval, which is you would get a portion of those items, and then you would put them in an algorithm, and then that algorithm would focus on their relevance. Let's say we picked 1,000 items, we rank them by the relevance to the user, and then we do another stage, which is the filtering. So we filter whatever items that we don't want to show to the users, and then we do re-ranking. So most of this fairness happens at the last re-ranking stage. However, if any, let's say, bias or unfairness happens in the previous stages, of course, whatever you fix at the end is not going to fix it. So let's say if I'm not picking the niche user from the beginning in my like first 1,000 item, that niche user is not going to make it to the end whenever I do like some sort of re-ranking. And that's where you see like most of the responsible AI work is happening in the re-ranking phase, because that's when you have the opportunity of like, okay, let me add users from this specific group. Let me put these users more on top of the list or something like that.
Well, re-ranking makes sense. It's intuitive. Are there other ways to approach the challenge?
That is where we come with our idea. So we were like, okay, we have the re-ranking, but what if we just make a new recommender system? What if we let people create it, or like algorithm developers have their own algorithms that they would attach to this platform, and then you would have like a curated algorithm. And by this plurality of algorithms, by having like more algorithms, we might curate to different users, and also different providers may make it to the consumer at the end.
Is that the s'mores framework we started talking about?
Yeah, the idea there comes from the algorithm store. The algorithm store have like two people started talking about it. There's like this manifesto, which is called like the three-legged stool. And the idea comes there from like, what if, for instance, on a platform like Mastodon, like a federated social media platform, what if you let users create their own algorithms, and then they would create their own needs? So you would have like, for instance, a user would choose from like a spectrum of algorithms. You're like, oh, I want this one that, for instance, gives content about this specific niche sport, and I don't want my niche sport to be within the like this big mega sports algorithm. So I'm gonna choose that one. And also, you can think about it as like an algorithm that fits my values. So if I am on DoorDash, I might want an algorithm with the restaurants with only like ethical meats or like kosher meat or something like that. So whenever we have this idea of like algorithm pluralism, we would have more opportunities for users to choose the path that they want. And there's this another idea by Fukuyama, which is the middleware, that is basically just the idea of like middleware in software engineering. So you would have this software that would work alongside the system, and it is more of like a modular component where you can replace one algorithm with another algorithm.
So this idea of the friendly neighborhood algorithm store is interesting. It's the opportunity for researchers like yourself to come up with a new idea and put it out there. Would then the platform, I don't know, do like a multi-arm bandit thing, or pick their favorites and experiment with them? Or is your vision more that the user has a choice here?
So we see it as the user has a choice. The closest example here is Blue Sky. So Blue Sky has this idea, which is I think started in like the past couple of years, which is the customized feeds. So you can think about it the same way. So the user would try to look up a specific feed or an algorithm. There should be like specific metadata about that algorithm and how it works, and then the user can choose their own algorithm. Because what we're trying to do is to lessen the control of the main platform that owns the item, let's say. We're trying to lessen the control of like what's trying to surface and give that control to the algorithm designer, because we don't want this centralized power of like only this platform can decide what the user sees. We want more people to decide.
I'm curious about, being able to have that choice, be empowered to pick my algorithm, but it's also another step I have to take. So what are you actually trying to measure in your experiments?
That's a really good question, and that is the question of the user burden. So like whenever we add more algorithms, we're asking the users to investigate and see their own algorithm and like find the one that serves them. And we try to see it more of like a subscription model. So like for instance, you choose whatever newspaper that you want to read, or like whatever streaming service that you want to use. And it's this same idea. So we started with this research question. Okay, if we have multiple algorithms instead of one, would that be beneficial to a specific group of users, or like the users who are interested in that specific content? Because there's no platform out there to try these ideas, we had to build our own environment. And we were like, okay, what is the best way to do this? And that's when we came up with the idea of what if we just make a simulation environment? So we're just going to simulate this whole basically ecosystem where we have providers and we have the platforms and we have the consumers. So basically, we use real data. So there are like multiple data sets out there that recommender system researchers and machine learning researchers use. So, for instance, one of the famous one is called Movie Lens, and that is user ratings data set. Like so, basically, user rated a lot of movies, and what we did there is that we took all of the movies like that are on the data set. We found their studios from a different data set. And then we were like, okay, these are the providers. So the provider is the studio in this ecosystem. And then we already had the users. So we used those users. And then the last part, which is the platform. And we basically, because we were thinking about this idea of like the algorithm store, we had to simplify it so we can measure what is that change. So we just created two recommenders. So like the store has two recommenders at this point. So it has one mainstream recommender and one niche recommender. The niche recommender basically focuses on a specific genre of movies, and the mainstream would just see whatever like other users on the platform wants to see. So we used an algorithm called SPD. Yeah, basically it's just like one of the popular recommendation algorithms. We ran the experiment and we had a multiple switching mechanisms. So we had a utility measurement, which basically says if the user does not see the genres that they want to see in a recommendation list, then the utility would decrease. And if they see the genres that they want to see in that recommendation list, then the utility would increase. And we had a specific threshold, and we said if the user's utility would drop below that threshold, then the user would go and choose a different recommender. So we had this idea of like a switch-in mechanism. By the end of the experiment, we found that users who moved to the recommender that tailored more to their needs would have a higher utility. And also the providers who did not make it in the mainstream recommender because they were a niche provider. When you have a recommender that focuses on their content, then it's really easy for those users to find that content instead of trying to find it in this abundance of content on the mainstream recommender.
How many logins does it take to answer one business question? ERP for orders, CRM for customers, HR for headcount, accounting for spend. Then someone sends you a spreadsheet that contradicts all of those other systems. Scalar ends that chaos. It unifies every business system, structured and unstructured data, into one governing source of truth. Ask questions in plain English. Get instant, accurate answers. No exports. No chasing people across tools. No more 3+ platform treasure hunts just to close a simple report. Scalar works with Snowflake, Databricks, and every other data provider you already trust. No migrations are required. It understands what your data means, where it lives, and gives you access 10x faster, saving you time and money. Go to scalar.com to get your free demo today. That's SCAYLOR.com. Once again, Scalar, SCAYLOR.com. Get a free demo of Scalar and finally unify your business data once and for all. So you mentioned having two recommenders, obviously the one's for mainstream and then one is niche. You said for a specific genre. Was there one genre you picked or did you have several niche genre models?
So we tried with different data sets. For the paper that we published, we had the horror for movie lens, so like the horror genre. And we used an Ambar data set, which is a music data set. And for that one, we used soul funk. For each data set, we tried one niche. Ideally, in a simulation environment, and that's the work that we're working on right now, you don't want just two. You want this idea of niche to expand. So let's say users who go below a threshold, and then you try to create a niche from that group of users below the threshold, and then until you reach X amount of recommenders. So having these strict simulation environments are really good in a sense of like, they would give you the first picture, like, oh, this is a potential thing. But I think there's a lot of work needs to be done to come to the idea of like, oh, this is the thing that we need to do. And these are like the clear trade-offs of this work.
Well, two different recommenders can differ in their training data, in their specific algorithm, or maybe just some parameters to the algorithm. How did your models differ?
For both of the recommenders, we wanted to be consistent in terms of the parameters. However, the data is what's different. So the niche recommender only recommends items that would have the genre that we defined. So let's say if we call it like the horror recommender, then we'd only recommend movies that has the horror genre. The mainstream would basically recommend everything. The data is also split. So as a simulation environment, the users would arrive. So let's say like the first day of the simulation, that's where the users are going to interact with the recommender system. But before that, the recommender system does not know anything about the user. So we're trying to simulate an environment that the recommender sees every user as a cold start case. So that's a new user. So because we start with the mainstream recommender, then the mainstream recommender would build profiles on the users, and then we'd use the data that the user selected as the training data for that user. And then when the user moves to the other recommender, the niche recommender does not know anything about the user at that point because it's also facing the same problem. If it's a cold start, this is a new user that is arriving. So we have this separation of data between the two recommenders. And that is a question that we're also interested in, which is, should users transfer their data? Like if I'm moving from one recommender to the other recommender, should I take my data with me? And there is a research that is evolving from the GDPR and some other legislations, which is the idea of data portability. So me as a person who's moving between recommenders, should I take my data with me? And how would that be even beneficial to the other platform if I take my data with me? And what are also like the trade-offs there?
In your simulation, the users are going to follow that switching mechanism you described earlier. Do you have any high-level observations about like how often they switched or things along those lines?
Yeah, so the users, or we call them like the niche users, which are the users who are interested in like the horror genre for movie lens or the soul funk for the armbar. Those users, I would say like 90% of them would switch to the recommender really early on, like the niche recommender. And then only few of them would keep switching back and forth. And we had this idea of like back and forth switching because some users would not find any of these two recommenders satisfying. So let's say we can group the users to like three groups. We have the people who have like the action and the drama. Those people are happy, like in their mainstream recommender, they're always gonna get the action and drama. There's an abundance there. And we also have our niche recommenders who are like really interested in the horror. So those would move to the niche recommender and they will be happy there. And then we have a group of user who would not be happy in these two. So this group of user will be like switching to the generic recommender. They would get good recommendations, then it's gonna get lower, then they're gonna switch to the other one. And that's when you need a third recommender to kind of like solve this problem. But you don't want to keep increasing recommenders until every user will get their own recommender, right? So there is like a threshold there that you need to find where, okay, until what point I can add recommenders while I'm adding value to the users? Like at what point does that stop adding value, let's say?
Well, the more traditional approach is just the monolithic recommender. It would have the mainstream one and that's it. How do you measure the improvement you get by adding in the option for the niche recommender?
Yeah, so we basically measure the utility for every provider. So for the providers, we measure their utility for the generic providers, and then we measure the utility for the niche providers. And then for the consumers, we do the same thing. We measure for the generic and the niche. And what we found that for the generic providers, they would use some utility because basically some of the like the views or the clicks that they were getting from niche consumers, and now those clicks are moving somewhere else. So like those niche consumers are going to click on like the niche providers. For the niche providers, they basically gain so much utility because they have a recommender for themselves and users. Whenever they go there, they'll be like, oh, this is like the niche content that I'm interested in. So every niche provider will get some sort of exposure on that recommender. As for the consumers, we also saw the same thing. So like niche consumers would have a higher utility. However, then the generic consumers, sometimes when they switch to the niche recommender, they only see stuff that they are not interested in. So if the consumer makes the switch to the other recommender, then their utility might drop. But we also found some users who we did not label as niche, but they stayed on the niche recommender because they liked it enough to stay there, or like they liked it more than the mainstream one. So there's definitely a trade off to make there. And for the provider trade off, I can argue that for those mainstream providers, like those clicks weren't supposed to be yours anyway, so they should go like to the niche. But for the consumer side, that's the one that you don't want. You don't want if I'm like interested in like comedy, don't move me to a horror recommender. That does not make any sense.
It's intuitive to me that a niche, horror lover who gets the niche recommender is more likely to enjoy it. And I see your point about there's a marginal cost. Those views went away from maybe mainstream providers. If there were a big platform, let's say it's YouTube or Spotify or whoever, who was interested in this idea, but the product manager says, well, I can't afford those costs. How do you look at it practically?
Yeah, that's a really good question. So I think because of the simulation environment that we are facing those costs. I don't think that those costs are going to translate directly to like those platforms. Because one thing, for instance, that we did not account for our simulation environment is the, say, like the name of the recommender. So for us as the creators, we know that that's a horror niche recommender. But in the switching, the user does not know that it's a horror recommender. They just think of it's like, oh, this is a different recommender that I need to check out. So let's say for thinking about a platform like YouTube, I like playing guitar, so I'm interested in like guitar content. So if someone created a recommender for guitar tutorials or like more specific like guitar tutorials with tabs or something like that, then I as a user I know that this recommender is for this specific thing. So that kind of like lowers this cost of the user seeing stuff that they don't like. And I would argue that me as someone who's like going to YouTube and seeing like everything on the same page, that's when I'm losing utility. And I would gain it more if I can choose what I want to see actually.
Are there any technical barriers to getting an idea like this, that there are third-party algorithms on a platform? Are there technical barriers to making that a reality?
There are some side effects of a recommender algorithm. So, for instance, we have the filter bubbles where everybody's seeing the same thing. So, like for instance, if you are either on social media and you're either like on the right or the left, you would only see content that is from that political spectrum, and that's what we call like a filter bubble. If you let users design their own algorithms, they might even exacerbate like that idea of like, oh, I'm just going to focus on this specific content. I'm not going to allow for any content from like the opposing party or like opposing ideology or even like slightly outside of that ideology. When Fukuyama introduced the idea of middleware, he said that a platform oversight might be helpful there. So the platform itself need to have a specific requirement for someone to create an algorithm. Another thing can be like a transparency. So we need to have more transparent algorithm development. Like, can the users, for instance, see this third-party algorithm and like how it's developed? And not everybody's going to understand like the technical part of that, but we know it's open for anybody who is interested. As for like the technical development side, because we see this idea of as like the platform has the storage of the content and these third party algorithms just have access to that storage, so like development wise it's not a very hard idea to develop. It's more about like all of these trade-offs that you need to consider, like as we said, like the user privacy, like is every third party algorithm going to own the data, is the main platform owning the data, and then these third party would have like a specific access. So there are a lot of things there that we like a platform needs to think about to make this happen.
So, what is the incentive for a platform to adopt third-party algorithms?
I would say the main incentive would be that users would have a better experience on the platform as they would find the content that they would actually interested in. Because I think there's also like different kinds of platforms. There are the platforms who focuses mainly on let me just like put more ads in front of the users. I want to surface specific material in front of the users. For those platforms, probably this is not what they're looking for. But with the platforms who actually want the user to have a good experience on their platform and they're not just trying to like go over engagement and these kind of things, those platforms basically can benefit because they are opening a new market where other ideas can come in and then those ideas might be a bit more beneficial to the users. So again, like back to this idea of me like in guitar, so a recommender that focuses only on that, that would be very helpful for me. Because like when I think about YouTube, there is what I want to see and there's like what the recommender is giving me. So what I want to see is more the things that are aligned with my interest, but the recommender is like, oh, you like this cat video, so you're only getting cat videos from now on. So this kind of constraints of a third party algorithm can help the user also choose what they want. then the user would be happier also being on a specific platform.
From your perspective, is there a trend in industry to move in this direction, or are we maybe just at the talking about it phase?
I think because Blue Sky had something similar, so at least we know that there is one part of the industry that is aiming it, like going in that direction, and it's very promising because they have this idea of like created feeds where users can create their own feed and add specific filters, and then you have a feed basically with a specific sort of content. And I think also there are some like startups that are focusing on this idea with like building feeds for Blue Sky. I don't remember the name of the one, the very famous one, but basically there are some companies who are helping users who are interested in creating their own feeds. I think Spotify, when they added this idea of like you create your own playlist, and even like YouTube, and then you can share your playlist, that is one version of it. That is one version of me like creating, tailoring content to other users. I would argue that Spotify's AI prompted stuff is like taken over, but a lot of like YouTube playlists are still very popular, I would say.
So the S'mores framework is available on your GitHub page. People can test it out or extend it or who knows what else.
Mm-hmm.
Tell me a little bit about that choice and about what users will find there.
Yeah, so we've been working on this simulation environment for almost like 2 years now, and just like tweaking stuff, adding stuff. It is on GitHub on our like that recommender systems lab repo, and once you go there, you can just clone it. There's information there about how to install it. We have also other repos for experiments. So if you want to see an example of how to run an experiment, we also publish the experiment repos, because we are separating of like this is the simulation environment, and we have other repos for simulations, like the experimentations that we use for our papers, and those usually would have like our results and our inputs. Yeah, it is available, and we did not talk about like contributions yet, but I'm sure that will happen at a specific point.
Very cool, yeah. Well, what's next for you?
So I am really interested in this idea of alternative recommender systems and user choice. The next study that I am interested in is, okay, so we gave users their own algorithms. Let's say we created this niche algorithm and users joined that niche algorithm. How can we allow those users on the platform control what is on the algorithm? So we go more to another form of user agency on the re-ranking stage. And I'm mainly thinking about it as recommender systems, like the group recommender lens. So if you have, let's say, even like a Mastodon instance with 1,000 or 2,000 users, how would those users decide what their recommender is going to look like? Or like if you have a subreddit, how would those people on your subreddit, if they have the chance, how would they choose what's allowed on their feed, how it's ranked, what is important to them? So moving more to the agency part.
Makes sense, yeah. And is there anywhere listeners can follow you online?
I'm usually active on LinkedIn. So you can type my name, Anas Buhayh, on LinkedIn, and I don't know if there's anyone out there with the same spelling of my name. So you're probably going to find me.
Lucky in that regard, yeah. Well, Anas, thank you so much for taking the time to come on and share your work.
Absolutely. Thank you, Kyle. Thank you for having me.